And now in this lecture we'll find out the area of the green shape. In the drawing we have a quarter circle. AOB is a quarter circle. We know that the radius of this quarter circle OB equals to 5 units in its length. This is angle NMP, that is a right angle. This is angle ONQ, that is also a right angle. We also know that arc AP equals to arc PQ equals to arc QB. So all the three arcs, AP, PQ, and QB, they are equal to each other in their lengths. Again, our mission is to find out the area of this green shape. So first of all, we will join points O and Q together by straight line. And we also join points O and P together by straight line. Here we can implement rule 20. On page quickly on rule 20. According to rule 20, in front of equal arcs there are equal central angles. So in the drawing we have a circle, and it is given as that we know that arc AB is equal to arc CD. In front of this arc AB we have this angle, that is angle alpha. In front of this arc CD we have this angle, that is angle beta. So those two central angles that are located between the equal arcs AB and CD are equal to each other. That is to say, because of the fact that arc AB is equal to arc CD, then angle alpha equals to angle beta. So we can actually implement this on 20 in our drawing. In our drawing, we know that arc AP equals to arc PQ equals to arc QB. And according to rule 20, in front of those three arcs there are equal angles. So those three angles, they are all located in front the equal arcs AP, PQ, and QB, therefore they are equal to each other. So if we define angle A or P as X, then angle P or Q must be also equal to X according to rule 20, and this angle Q or B must be also equal to X degrees in its side, because of the fact that all those three angles are located in front of equal arcs, and therefore they are equal to each other. So all those three angles are equal to each other. That is to say, each angle is equal to X according to rule 20. We know that AOB is a quarter circle. Therefore, this is again AOB, that is a right angle. That is to say, the sum of those three angles, X plus X plus X, must be equal to 90 degrees in their sizes. So 99, we shall find out that 3x is equal to 90 degrees. Here we divide this equation by 3, and finally we get that angle x equals to 90 degrees over 3 is 30 degrees. So actually, this is angle x is equals to 30 degrees in its side. This is also angle x, that is also equals to 30 degrees in its side. And finally, this is angle x, that is equals to 30 degrees in its side. So actually, in the right triangle MPO, this is the right triangle MPO, this angle equals to 30 degrees, this angle equals to 90 degrees. Therefore, this first missing angle must be equal to 60 degrees in its size. Why this angle must be equal to 60 degrees? Because of the fact that 60 degrees plus 30 degrees is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the right triangle NQO, this is the right triangle NQO. Again, this is the right triangle NQO. This angle equals to 30 degrees plus 30 degrees, that is 60 degrees. This angle equals to 90 degrees. Therefore, this first missing angle must be equal to 30 degrees in its side. Again, because 30 degrees plus 60 degrees is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. In the next step, I'll copy the right triangle MPO and this right triangle NQO in a new page, and we'll prove that those two right triangles can go into each other according to angle side angle rule. So actually, those are the two right triangles MPO and NQO that are going from the original drawing. In the next step, we will prove that those two right triangles can go into each other. So why those two right triangles can go into each other? So first of all, those two angles are both equal to 30 degrees, therefore they are equal to each other. So this is angle MOP. In the right triangle MPO, and it is equal to this angle, that is actually angle NQO. In the right triangle NQO. But again, if we found out then the angle MOP equals to angle NQO, they are both equal to 30 degrees, therefore they are equal to each other. In addition, those two angles, they are both equal to 60 degrees, therefore they are equal to each other. So actually, this is angle MPO in the right triangle MPO, and it is equal to this angle. This is actually angle NOQ in the right triangle NQO. So repeat again. Angle MPO in the right triangle MPO equals to angle NOQ in the right triangle NQO. They are both equal to 60 degrees, therefore they are equal to each other. And finally, PO equals to QO. Both PO and QO, they are the radii of this circle, and therefore they are the radii of the quarter circle, and therefore they are equal to each other. So PO equals to QO. Again, PO equals to QO, they're both the radii of the quarter circle, radius of the quarter circle, and therefore they are equal to each other. So if we proved that those two angles and the side that is between those two angles, that is side OQ in the right triangle or NQO, are correspondingly equal to those two angles, and the side that is between those two angles, that is side PO in the right triangle NPO. And therefore those two right triangles can go into each other according to angle side angle rule. So I write it down. So if I found out that the right triangle MPO congruent, this is the sign of congruent, to the right triangle NQO according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that the area of these two right triangles are equal to each other. That is to say, the area of this right triangle MPO is equal to the area of this right triangle NQO. So I write it down. The area of this right triangle MPO is equal to the area of this right triangle NQO. So repeat again. Because of the fact that those two right triangles can go into each other, we will derive that they have also same areas. That is to say, the area of this right triangle NPO is equal to the area of this right triangle NQO. Repeat again. Moving to equation 1, the area of triangle NPO is equal to the area of triangle NQO. The area of the right triangle MPO, this is the right triangle MPO. It consists of, the area of the right triangle MPO consists of, we define the intersection point between line 7 and Q and line 7 PO. This point is point S. So actually, the right triangle MPO consists of quadrilateral MPSN. So this is the area of quadrilateral MPSN plus the area of this right triangle NSO. The area of the right triangle NSO. Repeat again. We actually found out that the area of the right triangle MPO is equal to the area of the right triangle NQO. But the area of the right triangle MPO consists of quadrilateral MPSN and also the right triangle NSO. And therefore, the area of the right triangle MPO must be equal to the area of quadrilateral MPSN plus the area of the right triangle NSO. And it is equal to the area of triangle NQO. This is the triangle NQO. So the area of triangle NQO, it consists of two triangles. Triangle NSO, this triangle SQO. And again, triangle NQO consists of two triangles. The right triangle NSO, this right triangle NSO, and this triangle QSO. So write it down. The area of the right triangle NQO is equal to the area of this right triangle NSO plus the area of this right triangle and SQO. This right triangle is this is not right triangle, it is triangle SQO. And again, the area of triangle MPO is equal to the area of triangle NQO. Triangle MPO consists of quadrilateral NSP and the right triangle NSO. And therefore, the sum of the areas of quadrilateral NPSO plus the area of the right triangle NSO, in total, it is equal to the area of the right triangle NPO. And the area of the right triangle NPO equals to the area of the right triangle NQO. The right triangle NQO consists of two triangles. The right triangle NSO plus the area of the right triangle ASQ. So here we have the right triangle NSO on both sides of the equation, so we cancel the area of the right triangle NSO, and in total we found out that according to equation 1, the area of quadrilateral MPSN is equal to the area of the right triangle SQO. So the area of this quadrilateral MPSN is equal to the area of the right triangle SQO. So if we define the area of this quadrilateral MPSN as A, then the area of this triangle OSQ must be also equal to A, because they are equal to each other according to this equation 1. They are equal to each other. Okay. Our mission is to find out the area of this green shape. So what is the area of the green shape? From the drawing it is very easy to see that the area of the green shape is equal to the area of the green shape equals to the area of quadrilateral MNSP plus the area of this green triangle PQS. But again, if you found out that in total the area of the green shape equals to the area of quadrilateral MNSP plus the area of the green triangle PQS. But we already found out that the area of quadrilateral MPSN is equal to the area of triangle SQO. So we can substitute the area of this triangle on quadrilateral MNSP by the area of this right triangle SQO because they are equal to each other. So we do it now and get that the area of the green shape in total it is equal to the area of quadrilateral MNSP. And according to equation 1, the area of quadrilateral MNSP is equal to the area of triangle SQP. So we substitute the area of quadrilateral MNSP by the area of triangle SQP. Plus the area again plus the area of it is actually triangle OQS those areas that are equal to each other, that is to say the area of quadrilateral MNSP equals to the area of triangle OSQ. So we substitute the area of this quadrilateral MNSP by the area of triangle OSQ. So this is the area of triangle OSQ or OQS plus the area of triangle PQS. So today we found out that the area of the green shape equals to the area of triangle SOQ plus the area of this triangle, triangle PQS. And the sum of those two areas is equal to the area of sector POQ. Again, the sum of the areas of those two right triangles is equal to the area of sector POQ. So this is sector POQ. Again, the area of triangle SQO plus the area of triangle PQS. In total, it is equal to the area of sector PQO. Equal to the area of sector PQO. So in total, we should have found out that the area of this green shape equals to the area of sector PQO. So the area of sector PQO is equal to pi r squared. R is the radius of this quarter circle, that is 5. Is equals to pi r squared times 30 degrees, that is the angle between the legs of sector POQ. It is 30 degrees over 360 degrees. So in total, the area of the green shape equals to pi r squared. R is 5, therefore r squared is 5 squared, that is 25. So in total, the area of the green shape equals to 25 pi, and 30 degrees over 360 degrees is 1 over 12. So it is 25 pi over 12 square units. In terms of numbers, the area of this green shape is equal to 6.545 square units. Okay, again, if I found out the area of this green shape, it is equal to either 25 pi over 12 square units, so in terms of numbers, the area of this green shape is equal to 6.545 square units. Okay, so in the next step, I'll follow the lecture. In this lecture, our mission was to find out the area of this green shape. So in the drawing, we have the quarter circle, AOB is a quarter circle. We know that this is angle PMN, that is a right angle. And this is angle ONQ, that is also a right angle. We know that OB, that is the radius of this quarter circle, equals to factor incidence length. In addition, we know that chord AP equals to chord PQ equals to chord QB. Again, our mission is to find out the area of this green shape. First of all, we join points O and Q together by straight line, and join points O and P together by straight line. So here we can implement rule 20. I'll repeat quickly on rule 20. According to rule 20, in front of equal arcs, there are equal central angles. So in the drawing we have a circle, and you know that arc AB is equal to arc CD in its length. And according to this rule 20, in front of equal arcs, there are equal angles. So, in front of arc AB, we have this angle alpha. In front of this arc CD, we have this angle beta. And according to this rule, in front of equal arcs, we have equal central angles. That is to say, those two central angles that are alpha and beta, and they are located in front in the equal arcs AB and CD, must be also equal to each other. So here, from the fact that chord AB is equal to chord CD, we derive that angle alpha equals to angle beta. Why? Because those two angles are both located in front the equal arcs A, B, and C, D, and therefore they are equal to each other. Again, alpha equals to beta according to this rule 20. So we can actually implement rule 20 in our drawing. Why? Because in our drawing, we know that arc AP equals to arc PQ equals to arc QB. So in front of those two equal arcs, that is to say AP, PQ, and QB, we have equal angles. That is to say, all those three angles that are located in front equal arcs AP, PQ, and QB must be also equal to each other. So if one of those two angles is x, then the other two angles must be also equal to x, because they are equal to each other. So this is angle x, this is angle x, and this is also angle x. But we also know that AOB is a quarter circle, and therefore angle AOB equals to 90 degrees in its size. That is to say, x plus x plus x must be equal to 90 degrees in its size. X plus x plus x is 3x, so 3x must be equal to 90 degrees. So here we divided this equation by 3 and found out that x equals to 90 degrees over 3 is 30 degrees. So this angle AOP equals to 30 degrees in size. This angle POQ also equals to 30 degrees in size. And this is angle QOB that is also equals to 30 degrees in its size. Okay, so in the next step, so we know that if we focus on the right angle ONQ, and the right angle ONQ, this angle equals to 30 degrees plus 30 degrees is 60 degrees. So 60 degrees, this angle equals to 90 degrees, therefore the missing angle must be equal to 30 degrees in its size. Why? Because 30 degrees plus 60 degrees is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Okay, so in the right triangle NQO, this is the right triangle NQO, we have this angle equals to 60 degrees, this angle equals to 60 degrees, and this angle equals to 30 degrees. Likewise, if you focus on the right angle MPO, this angle equals to 30 degrees. This is the right angle, therefore this first angle must be equal to 60 degrees in its size. Why? Because 60 degrees plus 30 degrees is 90 degrees, and 90 degrees plus 90 degrees This is equals to 180 degrees. This is the sum of the angles in a triangle. So in the next step, I copy the right triangle MPO on this right triangle, and the right triangle NQO in a new page, and we prove that those two right triangles can go into each other according to angle similarity rule. So this is the right triangle NPO, this is the right triangle NQO that according to the original drawing, which we proved that those two right triangles can go into each other. So why those two right triangles can go into each other? First of all, those two angles are both equal to 30 degrees, therefore they are equal to each other. In addition, those two angles are both equal to 60 degrees, therefore they are equal to each other. And finally, OP equals to OQ. They are both the radii of the circle, therefore they are equal to each other. Actually, each radius is equal to 5 units, because you know that the radius of this concentric is equal to 5 units. So OP equals to OQ equals to 5 units in its length. So actually proved that those two right angles can go into each other according to side angle rule. And for the fact that those two right angles can go into each other, we derive that they have also the same areas. That is to say, the area of this right triangle NPO is equal to the area of this right triangle NQO. Repeat again. From the fact that those two right angles can go into each other, we derive that they have also the same areas. That is to say, the area of the right triangle NPO must be equal to the area of the right triangle NQO, because they can go into each other. Therefore, they must have also the same areas. The right triangle MPO consists of quadrilateral and MSPO, and also the right triangle NSO. Repeat again. The area of the right triangle MPO, actually it consists of this quadrilateral MNSP and this right triangle NCO. And therefore, the sum of the areas, the area of quadrilateral MNSP plus the area of this right triangle NSO, in total they must be equal to the area of the right triangle MPO. Repeat again. The area of the right triangle MPO is equal to the area of quadrilateral MPSN plus the area of the right triangle NSO. Because of the fact that the right triangle MPO consists of quadrilateral MSPN and the right triangle NSO. Likewise, it is equal to the right triangle NQO. This is the right triangle NQO. The right triangle NQO consists of two triangles, the right triangle NSO and this right triangle OSQ. Repeat again, the area of the right triangle NQO is equal to the area of the right triangle NSO plus the area of the right triangle SQO, because of the fact that the right triangle NQO consists of those two right triangles. Therefore, they must have also the sum of those two right triangles that must be equal to the area of the right triangle NQO. So here we have the right triangle NSO on both sides of the equation. So the right triangle NSO will get cancelled, and we left only with the equation that states that the area of quadrilateral MSPN is equal to the area of the right triangle SQO. Again, the area of quadrilateral MPSN is equal to the area of triangle SQO. So this is the area of quadrilateral MNPS, and it is equal to the area of this right triangle SQO. Those two areas are equal to each other according to equation 1. So if this area equals to A, then this area must be also equal to A. Okay? And the area of the green shape equals to the area of this green shape equals to the area of quadrilateral MPSN plus the area of this green right triangle PQS. Repeat again, the area of the green shape equals to the area of quadrilateral MNSP plus the area of the right green triangle. It is not right triangle, but is triangle, the green triangle PQS. Okay, again there are the green shape equals to the area of quadrilateral MNSP plus the area of the green triangle PQS. So there, but we already found out that the area of quadrilateral MPSN is equals to the area of the right triangle SQO. Therefore, we can substitute the area of quadrilateral MNSP by the area of the right triangle SQO. We did it, and we should found out the area of the green shape in total equals to the area of the right triangle SQO plus the area of the right triangle PQS. And again, the area of the green shape equals to the area of triangle PSQ plus the area of triangle SOQ. And the area of the sum of the areas of those two triangles, it is equals to the area of sector POQ. So in total, we found out that the area of the green shape equals to the area of sector POQ. Again, the area of the green shape equals to the area of the sector POQ. And the area of sector POQ equals to pi r squared, that is the area of the circle, times the angle between the legs of the sector, that is 30 degrees over 360 degrees. Okay, again, the area of the sector POQ is equal to pi r squared, that is the area of the circle in total, times the angle between the legs of the sector, that is 30 degrees, divided by 360 degrees. R is 5, that is to say the radius of this quarter circle is 5, therefore r squared is 5 squared, that is 25. So pi r squared in total, the area of the green shape equals to pi r squared times the angle between the legs of the sector, that is 30 degrees over 360 degrees. R is 5, therefore r squared is 5 squared, that is 25. So pi r squared is 25 pi. And 30 degrees over 360 degrees, it is 1 over 12. So in total, we actually found out that the area of this green shape, it is equals to either 25 pi over 12 square units. So in terms of numbers, the area of this green shape is equals to 6.545 square units. Okay, thank you very much.